All right. So as introduced, my name is Mashhood, and the correct pronunciation of the company is Sastatiket. It's a mesh between Urdu and English. Urlish, we call it. And I lead the engineering team over there. Sastatiket is a startup based in Karachi, Pakistan. That's where I'm from. And we're essentially trying to build a product that's similar to Expedia for our local economy and trying to bring offline travel management to online, like Expedia did. Besides the professional work that I do a lot of community work. So all of the logos that you see there are all different communities that I'm helping run in Karachi, I could be speaking to them, organizing their meetups or something of that sort. And because of that, I'm also part of the GDE team as well. So front-end, micro-frontends, yay. So a few weeks ago, this is in June, early June, Martin Fowler. How many people have heard of Martin Fowler over here? Wow, a few people, man. You guys need to look him up. He's a well-respected thought leader in Europe, and his essays are really good. They're usually going in depth about any technical detail that you might want, be it micro-frontends or microservices or whatnot. We saw a glimpse of him in the morning talk with Michael. He mentioned him when he was talking about some of the tech he was sharing. So Martin Fowler shared an article a few weeks ago, and that kind of triggered some conversations on Twitter. It was like a small explosion there. A lot of discussions going on back and forth, and this was part of the thing that was being shared. And no, this is not what micro-frontends are. A few of the conversations that were happening over there, people were not sure what's the whole point of micro-frontends. I thought it was a good thing to start from the why. What is the problem that we're trying to solve here? Let's try to define that. So we all know that if you're building an SPA, we have a very good established pattern to work on, the component architecture. And we also know that component architecture scales up pretty well. And if you use things like Redux or NGRX, you're pretty much good with large-scale applications. So we come to this question again. Why do we need micro-frontends? So let's start defining the problem a little bit. We want to start with this fundamental issue of scaling front-end teams. I think it was Mike's talk yesterday. He was talking about large teams or large-scale projects. So large-scale project does not only mean that you're running a large team. It could be a small team working for a very long time, and that's also a large-scale project. So, but when you start off, let's consider this scenario. You start off a new project. It's a greenfield project. You get to choose your own framework. Yay. You choose Angular, obviously, because Angular is awesome. And then you start developing on it. Over time, you start adding more code. You start adding team members. And what happens? What happens is that you start slowing down. Again, Mike mentioned something very interesting yesterday. The project that he left had not changed over the last 5 years. And why did it not change? Because it slowed down to a stop. It had become so complicated that nobody wanted to touch. It was impossible to debug. There was a lot of complexity involved. So if you look at the basic problem with scale, there are three main things there are many things, but let's focus on three main things over here. Code complexity. You have technical debt. That happens when you start adding more and more features, and you're no longer able to control the code base. You're not able to understand parts of it, so instead of going in and refactoring things, you start adding more and more code that leads to technical debt. And then when you have a large team, you also have a communication overhead. Take, for example, when you start off a project, you have two people, one working on the front end, one working on the back end. You're all pretty much in sync. You don't need any documentation, nothing else. But when you have a front-end team and a back-end team, you need to figure out ways to communicate effectively. Otherwise, everybody keeps fighting. Oh, but this was what I was expecting, and he sent me that, and then he sent me this. So how do we figure these things out? So the focus over the last a few decades, there has been a focus around how do we reduce complexity in our code bases. And one of the ways is to simply reduce the responsibility a single code base has. So at the start of the century, we were all making monoliths. We still make monoliths today. There's nothing wrong with them. But effectively, for large-scale applications, they're not considered the best approach just because of all the things we're talking about. Then after 2005, the browsers got upgraded. We started throwing more and more code inside our browsers in JavaScript, and the concept of a front end came into place. Then that got upgraded when frameworks like Angular JS came out, and we had single-page applications. And now with GraphQL, we're throwing even more code on the front end. So our front end now, I mean, I've heard that in Google there are several projects that go easily over 100,000 lines of code, right? So those are now large-scale projects happening on the front end. So at least for the backend side, over the last decade, they kind of figured out a nicer way of doing this, and that was microservices. So the basic idea remains the same. You take your large chunk, your large code base, and break it down into small independent services. And when you have these independent services, you have these small, manageable, cohesive code bases that you can use, and you can essentially treat them like small projects. And that allows you to move fast, that allows you to manage the complexity, and keep your team communication overhead low. And if you extend that same idea, you have micro-frontends, and that's where we get the name from. Now, and personally, I'm not a big fan of the name yet. I'm not sure why it's so popular. The important thing to note over here that you don't need microservices for micro-frontends, and we'll see why. There are different thoughts on this, but essentially the basic idea is that you want to take this big, massive monolith that you have for your front-end code base and break it down into smaller micro apps that can be deployed independently, and essentially makes it easy for all of us. So just a quick recap on why this is better, right? So we want to move fast. We want to sustain the pace. Moving fast is probably not even right. We want to reduce our code complexity. We want to reduce our technical debt, and we want to reduce communication overhead, right? So if we have all of this, we have some really good code base. We are able to move fast, and we're able to make awesome products. There is one other advantage that I'm actually quite a fan of, and this is for those people who are thinking of migrating from AngularJS to Angular, or it could be just any shift, incremental change in technology. That's what it's called effectively. And effectively, the idea is that you deploy both of your legacy application and the new application separately as two separate micro apps, and then your old app may or may not change over time. You don't really care, but your new app can evolve and slowly take over the other one if need be or not. Again, it's up to you. And essentially, you deploy the application over time. So this is also interesting, and we'll go a little bit into detail how we can do this in the upcoming slides as well. So now that we know why we want to create micro-frontends, let's start looking into what they actually are. So we got a glimpse of them already. They're an extension of microservices of sorts. But how do they work? So let's define the objective first. The objective is very simple, in theory at least. So all your front-end code runs in the browser on a single web page. Now, what you want to do is you want to take all of those little micro apps you've created, bring them together in the same web page, and give a seamless user experience to your users. It doesn't look very hard, but there are a fair number of complications that we'll discuss. So how do you do that? You create a stitching layer that effectively takes all of your micro apps and bundles them together before serving them to the user. So I'm going to run through a few different ways of how you can do this. And again, as I mentioned over here, micro-frontends, as of right now, is a very, very broad term. It doesn't apply to anything specific. So you'll find these ways on the web, and you'll find many other ways on the web of doing these things. So it's not like microservices now that, in most cases, people have a very standard stack of how do you go about doing it. We're still trying to figure out how to get these done efficiently. So the first one is the easiest one, and this is just simply using hyperlinks. Hyperlinks is what we're thinking. Yes, these are A tags, and essentially in this case, all you have to do is configure some settings on your server, and you can define your each template to render on a separate path. So each micro app comes on a separate path. A good example over here, let's say I'm making this huge enterprise application for your internal tooling, and it has a mail app, and it has a contacts app, and it has a contacts app, right? And a calendar app. So you can have a /mail, /contacts, /calendar, and when I go on each of these URLs, it independently loads the 3 single-page applications that I've made for there. So for this, you don't need that much tooling, just some server-side configurations. It's well supported, and all your JavaScript and CSS remain separate, so you're hitting all the good queues. But obviously, your user experience is not good, because when I move between my single-page applications, the micro apps, my page is going to reload every time. The second issue, and this is something you'll see in the upcoming slides as well, is that every time we change the micro app, it has to re-download the whole bundle again. And we might be using a lot of shared stuff, and it has to do that again and again for every micro app. So that's not super efficient. So we can make this better, and we can make this better by using iframes. And for those of you who are like, what, iframes? I thought we were done with them, but not yet. So iframes are, we love them and hate them, but over here, they serve a very particular use case. So instead of loading the 2 apps on click, you simply load the separate URLs on different iframes. And the way this works is that you have a very simple stitching layer running on your browser, and all it does is it looks at what URL is loading right now. So if I load the /mail URL, then it knows, oh, I want to show this iframe that has the mail app. Oh, now I'm opening a /contacts URL. I'm going to load the /contacts app. And you can lazy load your iframes, and you can show the one that's most relevant at that stage. So again, now we started adding some additional tooling on the front end. It's starting to get a little more complicated, but still very straightforward because you have separate deployments. There's no page conflicts. They're running on their own pages. Iframes, though, as you may all know, have issues. There are security issues. Each iframe opens a new process. So if you have like 50 micro apps, then, well, that's not going to work, right? Again, you have the same issue of downloading each bundle every time. That's not super efficient. So I think we can do better. Let's see how we can do this, how we can make this better. So now we look into this library called Single Spa. And this library is super awesome. It's open source. And what it does is it does the same things that we learned in the iframe thing, but it removes the iframe. So it loads your single-page applications into the DOM, multiple single-page applications into a single DOM. How it does is it takes the root element and places it in the body and initializes them as they're required. In order to get this running, you need to integrate this library into your code base. So it has recipes for Angular, React, Vue, whatever you're using, and you can actually run all of these frameworks side by side if you want. And it's pretty easy. It doesn't take too long. And then you have to create a separate container that essentially links all of these, and then it renders everything in that container. So our stitching layer has now started thinking. It's getting more and more logic in there. And now we have created this dependency of single-page applications into our own applications as well. And with this, we have now all our micro apps running on the same page, and they're seamlessly changing. We can seamlessly change between each micro app, and I think it all looks good. But now we started running into a different problem. Like, now we're sharing the JavaScript workspace, right? So if I have any global variables, if I have any libraries running, and I'm specifically pointing out Zone.js over here. So if I have different versions of Zone.js in my different micro apps, I can't do that using this strategy because it's simply not going to work. You can only have one Zone.js running. Obviously, you can do it, but it's going to be extremely hacky if you wanted to. And then, of course, you now also have to do custom tooling for your deployment because you have to generate that wrapper, and that wrapper then includes all of your different micro apps in there. The final approach, and this is slightly different from everyone else, is the web components approach. And some of the micro-frontends enthusiasts say that this is the real way of doing micro-frontends. I argue that that's not very true, because if you look at what the problem you're trying to solve, all of the other ways also solve the same problem. But effectively, the idea here is very simple. You take all of your JavaScript code, and again, it can be in any framework, and you compile it down to custom elements. Now, the additional advantage you get here is that you can start sharing your micro apps within the same view. And you have an example over here. So you can find more details on this particular strategy on microfrontends.org. But this is where you need an insane amount of tooling, just because your stitching layer is the one that places these components in the view. And then since these are all different microservices behind them, you don't know if any of these microservices is running slow or needs more time. So you have to start thinking about your loading states and whatnot. And obviously things like sharing routing becomes a little more harder as well, because that all goes into the container. So these were some of the ways that we can build micro-frontends. But taking a step back and trying to see, okay, fine, this is how we do this, but what's the main overhead? So let's talk about some of the overheads that we're getting by using micro-frontends. The first one, and the one that is talked most about, is bundle sizes. So a big one thing that people are against micro-frontends is the fact that they think that it's gonna create this situation where you're gonna have very large app bundles. So, which is fine, yes. We saw that every time you load a new app, you have to re-download the whole bundle, which is not good. So how can we fix that? But before we look into that, here's an interesting question. Is that even a concern? Now, in most cases, yes, it is a concern. You do have to keep your bundles small if you're shipping to your users. But I've worked on enterprise apps where everything is running on local area networks. In that case, you're pretty safe to get away with slightly larger bundles, and it's completely fine. But in most cases, yes, you will need to trim down those bundles. How do you do that? Dynamic bundling is available. You have System.js, one of the libraries that can do this. And effectively, you have to configure System.js on the client side to essentially make sure that you've optimized your chunks properly, and it only downloads the stuff that it needs to on the client. The other way of doing this is doing this on the server side. So when you create your build, you essentially assess all your micro apps, and you see, okay, these are the common elements, and you create your chunks likewise. This is not a very good idea, again. Why? Because let's say I have 50 micro apps, and I'm continuously pushing on each one of them. Each push on any micro app will deploy my complete front end, all the 50 micro apps. So not the best way, but again, it's going to depend on what works for you, right? So these are all different ways of solving this problem. Syncing between application states. So when you have different micro apps, you will need to share the state between different micro apps. This is going to happen, right? So so for example, I have an application that uses a user object. I've logged in a user, and now I have to share my user object. One way of doing that, and this is the most common way, there are other ways of doing this as well, is local storage. And you can use local storage by simply listening to events on specific keys. And when they update, you can update your app accordingly. You can also sync the state on the back end. So let's say I have a shopping cart app. When I add a product to my cart, it goes and gets stored in the database. When I load my cart single page application, it will download the data and show that instead. One other way that I haven't mentioned over here that's very popular is also events. So you can just throw events around, but it's harder to do that because you don't know if your other pages are listening or not, because they're lazy loaded. So if they miss the event, then they might not get the data. So these are the more popular ones that people are using. Maintaining consistent design. This is an interesting problem. When you have independent teams working on different apps, so the idea is to reduce communication between the teams, but how do you maintain UI consistency, design consistency? Now this is a big problem anyway, and Microfrontends does not make this easier in any way. I've put a picture up there of Amazon, and you can see that even if you go through Amazon, each page is usually controlled by a separate team, and you can see the inconsistency in design as you go across. How can we reduce this? So obviously, the easiest way to do this is by simply having a style guide. But a more interesting approach to this is having a design guild team. And what that is effectively across all your different teams, you pick specific people that champion your design and UX. And they ensure that when you're moving between different micro apps, you have the level of consistency. And a simple example for this is your toast, right? Whenever you show a toast in our application, it comes from the right on top. You want to make sure that every single micro app is adapting that. And the reason this is so hard is, especially in micro-frontends, is because you want to keep your design separate for each app, right? So each team should be handling their own design components. And why do we want to do that? Again, it's the independent part that's the most important here. Because if I have a shared UI library that I'm using across 50 apps, and then I change one component, I have nowhere to know that if I've changed or destroyed something in the other 50 micro apps that I have. So instead of having the shared library, what you end up doing is having duplicates in each micro app. So it's kind of a step down. It's not like one of your recommended engineering practices, but when you're working at scale, you have to make certain compromises. And finally, tests. I hope everyone here writes tests. And if you're writing micro-frontends, the basic objective over here is that all your tests should be independent as well. So each micro app is you're going to write tests for that, and it's going to run independently. And then at the end, when you deploy or before you deploy, you should have some E2E tests that integrate everything and run across micro apps to ensure that everything is working fine. So that was a quick run-through of what micro-frontends are and how we go about using them. I would like to wrap up by saying that this is a fairly large, so this is like microservices, right? This is not something that you can usually cover in 30 minutes. So what I've given you is just like a glimpse of what the actual thing is about. Again, like with microservices, you need to think about what's the end goal over here. If you're trying to do micro-frontends, what is the real purpose? And in most cases, what we're trying to do is trying to create maintainable code bases and independent teams so that we can have things like you can deploy it anytime you want. And essentially, you can move fast and create awesome products. Final recommendation will be to tread cautiously. And this is, again, my own experience. We've struggled a lot with building them so far. The overheads are not very obvious, and when you start getting into it, it tends to get a little more complicated than it seems initially. Here are some resources that I went through initially with, so just put them here. I'm going to highlight Mosaic, that's the last one. It's a framework that does the web component style micro-frontends. So it's super interesting, very similar to single SPA as well. And that was it from my side. Thank you all so much for having me here. All right.